Hey everyone, do you know what's the difference between an equation and an expression? In terms of the way they are being handled, you simplify an expression while you will solve an equation. Also, an equation can be thought of equating two expressions together. In this segment, we will be looking at solving equations where indices are involved. We will use the following few examples to establish the idea of what this entails. Let's take a look at this first example. In example 17, to solve this equation, we need to change both sides of the equation to a common base. At this point, I hope you are also able to immediately identify that 8 is 2 to the power of 3 and that 1 over 8 is 2 to the power of negative 3. Also, 16 is 2 to the power of 4. You can think of 16 as 4 times 4. 4 is 2 to the power of 2, so 16 is 2 to the power of 2 times 2 to the power of 2, or 2 to the power of 4. 2 to the power of minus 3 is raised to the power of x in this case, which is then equated to 2 to the power of 4. To simplify that, you get 2 to the power of negative 3x, which is equals to 2 to the power of 4. By comparing indices, you will get negative 3x equals to 4, and then you'll get x equals to negative 4 over 3. Example 18 is similar to the previous example. 27 is 3 to the power of 3, and 1 can be written as 3 to the power of 0. So the equation can be rewritten as this. And using the first law, we can write the equation as 3 to the power of 3x plus 1 equals to 3 to the power of 0. Next, comparing the index on both sides of the equation, we will get 3x plus 1 equals to 0. And rearranging the terms, we will get x equals to negative 1 over 3 as the answer. There may be cases where the numbers are large and you may feel slightly intimidated upon first look. But you can easily handle that if you think of breaking it down into its prime factors. That's a topic being taught in Secondary 1 called lowest common multiple and highest common factors. Now, let's take a look at example 19. So, 243 is probably a number you can't see in index notation at first glance, unlike 8 or 27. To start putting it in index form, first choose a prime number that you think may be a factor of 243. In this case, with 3 as the last digit, you can make a quick guess that it can be divided by 3. That will give you 81. From here, it gets easier. 81 is 9 times 9, which is then 3 to the power of 2 times 3 to the power of 2, which is 3 to the power of 4. And using the first law, 243 can be written as 3 times 3 to the power of 4, which is 3 to the power of 5. Hence, you can rewrite the equation to be 3 to the power of 2x minus 1, which is equals to 3 to the power of 5. And by comparing indices, you will get 2x minus 1 equals to 5. Making x the subject, x will be equals to 3. Let's move on to a slightly more complex question. In example 20, numbers 64, 16, and 4 can be expressed as a common base of 2. The equation can be written as this. Simplifying both sides, we will get 2 to the power of 6x plus 6 equals to 2 to the power of 14x. And by comparing the index on both sides, we will get 6x plus 6 equals to 14x. Simplifying, we get 8x equals to 6. And then we make x the subject, getting x equals to 3 over 4. Let's do another example, shall we? In example 21, 2401 is also a large number which you may not have an idea of its index notation at first glance. However, by looking at the other numbers in the equation, you may notice that 7 is a possible base number. Since the denominator of the term on the left is 7 and 343 is 7 to the power of 3, we can first divide 2401 by 7 and we will get 343. So 2401 is 7 times 343, which is 7 times 7 to the power of 3, and can be simplified further to become 7 to the power of 4. So this equation can be written as this. As we simplify this equation, we will get 7 to the power of 4x plus 3 equals to 7 to the power of 6x. By comparing indices on both sides of the equation, we will get 4x plus 3 equals to 6x. And making x the subject, we will get x equals to 3 over 2. It's time to try some questions on your own. With more practice, you'll definitely get much better. Take some time to explore more questions before moving on to the next segment. And when you're ready, I'll see you in the next video.